The formula that's going to tell us that a graph is an exponential graph, by which we mean it grows extremely quickly, is this: y equals a constant multiplied by another constant to the x plus a q. So here, what's different to what we've used before is the fact that there are 3, not just 2. Okay, now we've experienced this q before, which is the shift up and down. It is no different with the exponential function. So when it is positive, we have a shift up, and when it is negative, we have a shift down. The a value is going to tell us the vertical stretch, and it's also going to tell us the shape, just like the hyperbola. So this is what exponential graphs look like. When you have a positive a value, then you're going to get a graph that will point upwards. You are also going to get one that could be a decreasing function, also pointing upwards. When a is negative, you're going to get a graph that graphs that are reflections of these in the x-axis. So this one will reflect that way, and this one will reflect that way. And getting used to these pictures really does help you understand how these graphs can look. Right, the b value is a bit more technical. This one will tell you the steepness, so how fast it grows. B is quite special, and this you need to remember. Okay, b can never be 0. B can never be 1, because then there would be no point. And b can't be negative. So what can be? It can be something that's bigger than 1. Okay, so b can be bigger than 1. And b can be a positive fraction. So b can be positive fraction. Right, and what will that tell us? Here, if b is a positive, it'll look like that. So that one. And that is if b is bigger than 1. If b is a positive but a fraction, it's going to look like that. So that one. And then if they get reflected, it'll be because of the a value, which will reflect them in the x-axis. A graph where the q value is 0, or in other words there is no q value, is going to look more or less like this. Okay, if b is a number bigger than 0. But let's add on a q value and see what happens. We're going to end up with an asymptote. So here the asymptote, you can see what's happening. This approaches there, and it approaches the x-axis, the line y equals 0, and that's an asymptote here. But if we subtract, say, 2, and we take the graph of whatever this is, and we minus 2, so the q value is going to be negative 2, just going to estimate, and I'm going to put in an asymptote here. And if we move everything down, you're going to see that it'll be exactly the same as that, only now it's going to tend towards this line over here. So the generalized exponential function looks like that, or we sometimes call it the mother graph. And then if you shift it up or down, it's going to be exactly the same shape, just shifted down that way. And it's exactly the same if it's one that looks like that. It'll shift down here, and if it is one that looks like that, the asymptote is above. And in this case, the asymptote would also be above. So again, getting used to the way that these things look is really helpful, so you can pick which of the 4 is your graph. So what are you expecting when you draw it? To show you how to draw these graphs, I'm going to show you 2 different ones. Here, your A value is positive, the B value is a number that's bigger than 1, and then it's to the x, and there is no Q value, which means your asymptote is the x-axis. In this one, the A value is negative, and the B value is a fraction, and the Q value does exist, so the whole thing's being shifted up, so that you can see the spectrum of the different kinds of graphs. So the first thing we're going to do is we're going to write down and then draw in the asymptote. So for f of x here, we're going to write down the asymptote. Now there is no Q value, so the Q value is the x-axis, which is the line y equals 0. So we know that that graph is going to tend towards this thing, but that's all we know about it at the moment. Okay, so then the next thing is going to be the intercepts. They may or may not exist. There will normally be a Y-intercept. There may not be an X one. It really depends. Okay, so let's try. So for f of x, we're going to find the Y-intercept, if it exists, which means we let x equal 0. So that means for the graph y equals 2 times 3 to the x, we're going to let x equal 0. Now, with exponential understanding, we can do this in our heads, but I recommend, because your focus needs to be on graphs right now, that you simply plug that into your calculator. You're going to get out 2, because that's 1. So I'm going to have 2. That point, which is important to write down, because it is an intercept, is the point where x is 0 and y is 2. So that is the y-intercept for the f of x graph. Okay, what about the x-intercept? Let's see. So my x-intercept is going to be the place where I let y equals 0. Look what happens here. So we're going to say 0 equals 2 times 3 to the x, and I'm going to try and solve for x. So this is essentially an exponential equation. Okay, divide both sides by 2. 0 divided by 2 is still 0. 0 equals 3 to the x. Now that's not possible. You can't have a power that gives you something as 0 as your answer. So this means I have no solution. But the other thing you can use, if what I've just said there doesn't make sense, is because there's no Q value, it means there's no x-intercept. Okay, so that's also something to just remember. If there's no Q value, then there is no x-intercept. Right, so you've got the intercept, one of them, and then you don't have the other one, and you do have the asymptote. So what do you do if you don't have the one intercept? Well, you're going to do some plotting and a little bit of table method, or you can just actually substitute in a negative and a positive value for x and sub in to get y values. Because I don't have one of the intercepts, I'm going to need something else to plot, or I won't be able to show the shape. What I'm going to do is use one negative value for x and one positive value for x. Again, I'm using the calculator, so I'm not showing you that step. I'm subbing in -1 for the x value, and I get out 2/3 for the y. And when I sub in a positive value, I get out 6. If this doesn't work with something I can actually plot, I might try -2 and +2 and play around until I get something I'll be able to plot. But I can estimate 2/3, and if I can't estimate accurately, I can definitely label it accurately, so that'll be fine. Now I have enough points to plot this graph. Okay, I know from the formula that I'm going to have a graph that looks like a shape where it moves that way. And I'm going to plot the asymptote first, just like with a hyperbola, so that I know the framework I'm dealing with. Okay, so this one's asymptote is obviously the line y equals 0, so it's this line over there. So just for the sake of being very clear to myself, I'm just going to use color here. You don't have to do this in a test. It's just to help us understand that the graph does not touch that line. Okay, now my y-intercept I do have. My y-intercept is 2. So it's that one. Okay, it's the point 0 and 2 which I've got, and remember that there wasn't an x-intercept, so I had to plot a few other points. Okay, -1 and 2/3 I can do, so -1 and then 2/3 on the on the y is about there, just estimating, but I'll label it to make sure it's clear. And then the point 1 and 6, so 1 here, and then 1, 2, 3, 4, 5, 6 over there. Okay, this is what this one's going to look like. And it's not going to touch that axis. Okay, labeling my points 1 and 6. And this one is the point -1 and 2/3 over there, and then that's all. This line is the line y equals 0. So I'm going to label it because it's relevant to this particular graph. That's enough. I've got a point on the left side and a point on the right side, and that's important to have for an exponential graph. Moving on to the g of x graph, so that one, I'm going to put its asymptote down as well. So the g of x asymptote I read straight off the graph, it's 1. It's the line y equals 1. I'm going to draw it in a moment, and it'll be the first thing that I draw when I put the graph on the Cartesian plane. Right, now my intercepts for the g of x graph, so I'm going to go with the y-intercept, where I let x equal 0. So the y-intercept is where y equals -3, a third to the power of 0 plus 1. When I type this into the calculator, I get out -2, which is the point 0 and -2. So that is the y-intercept. Okay, we already know that the x-intercept, if there's no q value, doesn't exist, but here there is a q value. The q value is 1. So we're going to use our formula for letting y equal 0 to get out an x-intercept. This time it does exist. Okay, so for the x-intercept, we're going to let y equal 0. So we're going to say 0 equals -3, a third of x, a third to the power of x, plus 1. Okay, here exponential equations are going to be quite useful. So we're going to move that -1 across. I'm going to have -1, and that's going to be -3 times a third to the power of x. Going to divide by that. Negative divided by negative is a positive, so I've got a third equals a third to the x. That's a third to the 1, right? So x equals 1. So here, the x-intercept is 1, which is the point 1 and 0. And I can plot this straight away. Remember that the first thing you're going to plot is the asymptote. The asymptote is the line y equals 1. So I can put this one in, and I can label it as the line y equals 1. Color is very useful here. You may not use color in matric files. You've got to use a pencil. But for learning it, color is really helpful. Then I do have another 2 points. I have the y-intercept and I have the x-intercept. The y-intercept is that point 0 and -2, so it's down here. And the x-intercept is the point 1 and 0, so it's down there. So how do I know now what shape this graph has got? Well, I know that the a value tells me. The a value is negative. Because the a value is negative, I know that I'm going to have a graph that points downwards. So the only way I can get one that points downwards and that inches towards this asymptote is if I have one that scales more or less like this. If you want more evidence to prove how this shape works, if you need to see how it works, plot in a negative x value and plot in one that's bigger than 1, like plot in x equals 3 or 4, and see if you can create a more comprehensive shape just for your own understanding. The way graphs transform is quite important to graph interpretation when it comes to the exponential function, because there's quite a bit going on. There's lots of different ways in which graphs can transform. Okay, so I'm going to look at what we could call a mother graph, so one that doesn't have too much shifting going on, and I'm going to write y equals 2 to the power of x. Okay, this will look like that. Okay, so that is when your b value is bigger than 1, your a value is just 1, there isn't a q value. It's going to cut the graph there at 1. It's going to cut the y-axis at 1. Okay, if we then reflect that, so if we reflect y equals 2 to the x, okay, if we reflect that in the x-axis, so this one, so if we reflect it like that, okay, so it's now been moved that way, then when you reflect in the x-axis, then y becomes negative. If you reflect in the y-axis, x becomes negative. Okay, so here your y becomes negative. So that means you've got negative y equals 2 to the x. You obviously still have to solve for y, so that negative is going to move across, and you've got y equals negative 2 to the x. So when you reflect, then this whole thing becomes negative. So your a value changes to a negative. Here it was positive 1 because there's nothing there, and here it would be negative 1 times 2 to the x. So it would be positive 1 times 2 to the x. So reflection in the x-axis is what happens when you change the sign of the a value. Okay, now if you reflect it instead in the y-axis, so x becomes negative. So here it's going to be exactly like that, excepting it's going to be this way. Okay, so that is that one reflected in the y-axis. Okay, so I'm going to write that here. If I reflect y equals 2 to the x, this time in the y-axis, remember if you reflect in the y-axis, then the x's become negative. So then what I've actually got is I've got y equals 2 to the negative x. That can be written with b, the b value, which is 2, being a fraction, because we've got a negative exponent, so that could be written as 1 over 2 to the power of x. So now it's become a fraction, or you can say the x is negative. With that in mind, it's reflected in the y-axis. So when your b value is a fraction, it's a decreasing graph that looks like that. The last reflection I want to look at is if I take this one and I reflect that in the x-axis. So it's already been reflected in the y-axis, and then I reflect that same one, that in the x-axis, so like that. Okay, so that's been reflected. So I'm saying here, I reflect y equals 1/2 to the x in the x-axis. Okay, now remember, if you reflect something in the x-axis, then the y's become negative. So actually what that is, so the y becomes negative, so this y becomes negative, which means the stuff on the right hand side becomes negative. So it would be negative y equals 1/2 to the x, but now I'm going to move that negative across so that I have y as the subject of the formula, which is how functions work. So that means I have negative 1/2 to the x, and that'll be that one. If you can remember these 4 options, then when you read the formula for the different graphs that you have, you'll get a sense of how the pictures work and how each of them are reflections of the others. Then, like with all the other graphs, you can shift things up and down. So depending on your q value, so if we added +1 there, then this whole thing would shift up, and if we did an extra 1 there, then we'd have that exact same graph but shifted up. And if this graph went up by 1, then your asymptote would be there, and it would look like that. And if this one went up, your asymptote would be there, and it would look like that. And again, asymptote up, and then this one's going underneath the asymptote, so it would run like that. Okay, so the shifts up and down are pretty predictable because they run exactly the same way as the parabola and hyperbola that you've already done. Domain and range are also pretty repetitive in terms of the graphs you've already looked at. And remember that domain is how far left and right these go, and range is how far up and down. These will be x values and these will be y values. So if we just look at this one here of y equals 2 to the x, and we say, well, how far left and right does it go? This can be anything. It'll go infinitely to the left and right. Look at this kind as well. Infinitely to the left and right, all of them. So x is an element of real numbers for the majority of these graphs, all the ones that we're studying in grade 10. Okay, the y's is going to change things, so the range will be different because of the asymptote. So y can be anything up to that asymptote, and then it doesn't exist anymore, because here with that asymptote it doesn't go any lower than. So depending on the graph, the y value will be either from the asymptote upwards, or here from the asymptote downwards. So you will merely say that it is excluding that line that is the asymptote. So I'll do it for this one. So this one's range, I'm going to say y can be anything from the asymptote upwards. And in this case, the y equals 2x asymptote to 0. So I will say y can be anything greater than 0. And you can write that in interval notation alternatively if you prefer. When we look at the values for which an exponential function increases or decreases, we go back to our ruler test. When you have this type of exponential function, this one always increases. Here, when we reflected it, this one always decreases. This one also always decreases, and this one always increases. So with exponential functions, they are either decreasing or increasing. They either increase all the way or they decrease all the way. So you will say they are increasing for all values of x, or you can say they're decreasing for all values of x. And you've just got to make sure that you get the right distinction by using the ruler test. Finding the equation for an exponential function is a little bit different to what we've had up until now because there's more variables. So your general formula is this. We've got ab to the x plus q. And there's quite a number of different things that can happen because you've got your three numbers that you'd have to find in order to make this an accurate formula. Okay, so you could be given different things, and then you've got to solve. So what they often give is they give, say, a partial formula. So they'll say, they'll give you, say, y equals a that they don't have, and then they'll tell you that b is 2 to x, and then they will tell you that you're adding q. Okay, so they could give you that, and then they might give you, so that let's say that that is given, okay, and then they might also give you a sketch that shows the asymptote and perhaps the y-intercept. They'd have to give you a bit more than with the parabola and hyperbola because there are more variables here. So, if you have the asymptote, then you immediately have the q value, so you can plug it straight away in. If you have the y-intercept, then you're going to plug that in as well, because you must remember that the y-intercept is actually a point. That means that it's the place where x equals 0. It's going to be 0 on the x and then some other point there. And you can plug that in into x and y. Then you've got q, x, and y. You plug them all in, you get out a once you've solved the equation, and then you plug them all back to get into standard format. So that's the first case that they can give you. Another option is where they give you, again, a partial formula. They tell you that it's -1, so we know that it's being reflected in the x-axis. And they may give you a sketch showing an x-intercept, which means you've got a point where you get something that they give you, and you know that y is 0, because they're actually giving you a point when they give you the x-intercept. Okay. Then if they also give you the asymptote, you have enough. Here, you would be trying to solve for the b value because they've given you a as -1. They'll give you x-intercepts you can sub into x and y, and giving you the asymptote gives you q. You've got to get it back into that format so that you've actually found the equation for the graph. Just a note, if you get given a sketch where it actually goes through the origin, don't think that you haven't been given enough information, because that is actually the point 0, 0. So that's x, that's y, and you can sub that in to the formula that you have if they give you a partial formula.